we are asked to find the area of the segment in blue color, which is this segment here. Let's label it P. If this line AC here is a tangent to the circle at this point A. And we can see that line AC is also one of the three sides of this triangle ABC, which is 6 centimeters in length. This angle here 40 degree and this here 30 degree. So how can we find the area of the segment P? One of the ways to find the area of a segment is by drawing out the sector of its area and subtracting the area of the triangle formed by the radii of the circle and the chord from the area of the sector. So now we can form an equation that area of segment P equal to area of sector minus area of triangle. But what are the areas of the sectors and the triangle? The formula for the area of a sector is theta over 360 pi r squared. Theta is this angle here subtended at the center, which is unknown. Pi is 22 over 7 and r is the radius, which is also yet to be known. So what are the values of r and theta? That's what we are going to find now. Let's start with the radius. How can you find the radius now? From this chord AB here, since the formula for finding the length of a chord in a cycle is 2r sine c over 2, where r is the radius and c is the angle subtended by the arc to the center, we can say line AB equal to 2r sine open bracket c over 2. So from this triangle here, ABC, since we have the length of this side, we can find the length of this line AB here using the sine rule. So using the sine rule, line AB over sine 30 degree equal to 6 over sine 40 degree. Making line AB the subject, we multiply both sides by sine 30. So here, line AB over sine 30 times sine 30 equal to 6 over sine 40 degree times sine 30. Here, sine 30 cancels sine 30, and here, 6 over sine 40 degree times sine 30 is 4.667. So line AB equal to 4.667 centimeters. Substituting it here now, 4.667 equal to 2r sine c over 2. To find r, we still have an unknown, which is angle C. So what is angle C? Recall, line AC is a tangent at this point. So if we draw out a chord from this point here to this point, in the circle theory, there is a rule that the angle formed by the tangent of a circle and its chord is equal to the angle the chord subtend to the circumference in the circle. So that means this angle here and this angle are equal, and hence this is also 40 degree. So now if you look, this angle here is an exterior angle of this triangle here, and we know that the exterior angle of triangle is equal to the sum of the two interior angles that are opposite to it. And that implies that this angle here must be equal to the sum of this and this angle here, and hence equal to 40 degree plus 30 degree, which equal to 70 degree. So this angle here is 70 degree. Now since we are solving for the value of C, which is the angle chord AB subtend to the center, and we have this angle here at 70 degree, which is the angle it subtend to the circumference. In the circle theory, there is a rule that the angle at the center is twice the angle at the circumference if subtended by the same arc. So that means this angle here is twice the size of this angle here, and hence equal to 70 degree times 2, which is 140 degree. So C9 equal to 140 degree. Substituting it here now, 4.667 equal to 2r sine open bracket 140 degree over 2. 140 degree over 2 is 70 degree. So now 4.667 equal to 2r sine 70 degree. Making r the subject, we divide both sides by 2 sine 70 degree. Now r equal to 4.667 over 2 sine 70 degree, which equal to 2.48. So r equal to 2.48 centimeters. So you can go ahead and substitute it into this equation here of the area of sector. So area of sector now equal to theta over 360 degree times 22 over 7 times 2.48 squared. We still have to find theta, which is this angle here. So how can you find it? If you look, this angle here, theta, and this angle are subtended by the same arc. And we know that the angle at the center is twice the angle at the circumference. So that means theta is twice the size of this angle here. And hence we can label this x and say theta equal to 2x. But what is x? From this triangle here, since this is 40 degree and this is 70 degree, this must be equal to 180 degree minus 70 degree minus 40 degree, because the sum of angles in a triangle must always be equal to 180 degree. 180 degree minus 70 degree minus 40 degree is 70 degree, so x equal to 70 degree. And if x equal to 70 degree, theta must be equal to 2 times 70 degree, which is 140 degree. Substituting theta equal to 140 degree now, area of sector equal to 140 degree over 360 degree times 22 over 7 times 2.48 squared, which equal to 7.52. So area of sector now equal to 7.52 centimeters squared. Substituting it here now, area of segment P equal to 7.52 minus area of triangle. So if you look now, this triangle here is an isosceles triangle because two of its angles are equal in size. This is the base because it's facing the vertex angle. So this side here is equal to this side and hence equal to 4.667 as well. Now to find the area of this triangle here, since it is an isosceles triangle because two of its sides are radii of the circle which are equal, and this is the base because it's facing the vertex angle. The formula for finding the area of a triangle is half base times height. The base is this side here, which is 4.667 centimeters. So base equal to 4.667 centimeters. Now what is the height? The height is always perpendicular to the base. So now, taking only this side here, we are having a right angle triangle with this side here as the hypotenuse. So since we have the length of the two of the sides, we can use the Pythagorean theorem to find the length of this side here, which is the height. The Pythagorean theorem, we all know, states that the square of the hypotenuse of a right angle triangle is equal to the sum of the squares of the two other sides. If we apply this here now, since this is the hypotenuse, 2.48 squared equal to 2.3335 squared plus height squared. Making height the subject, height equal to square root of 2.48 squared minus 2.3335 squared, which equal to 0.84. So height equal to 0.84 centimeters. And we have the base to be 4.667. Substituting into this here, area of triangle equal to 1 over 2 times 4.667 times 0.84. which if you press your calculator equal to 1.9601. So area of triangle now equal to 1.9604 centimeters squared. Substituting here now to find the area of segment P. Now area of segment P equal to 7.52 minus 1.9604, which is 5.5596 centimeters squared. So find the area of segment P to be equal to 5.5596 centimeters squared. The question says find the length of each side of this triangle here if the total surface area of the triangle is 3.46. and angle ABC is equal to 3 times angle ACB, which equal to 3 over 2 times angle BAC. So how can we solve this? The formula for the surface area of triangle is half base times height. So let's equate half base times height to 3.46. So now half base times height equal to 3.46. So what are the base and the height of a triangle? To know the base and the height of a triangle, we need to know what type of triangle it is, and for that, we need to know the sizes of its angles. Though we don't know them, but from here, since angle ABC is equal to 3 times angle ACB equal to 3 over 2 times angle BAC, it tells us that angle ABC is equal to 3 times angle ACB, and 3 angle ACB is equal to 3 over 2 angle BAC. So let's say this angle BAC equal to X. Substitute it here. So if angle BAC equal to X, 3 times angle ACB will be equal to 3 over 2 times X. Dividing both sides by 3, 3 angle ACB over 3 equal to 3 over 2 over 3 times X. Now angle ACB equal to 3 over 2 over 3 times X, which is the same as 3 over 2 divided by 3 times X. So taking the reciprocal of 3 now, we have 3 over 2 times 1 over 3, all multiplied by X. Here, this 3 goes with this 3 here. So this angle ACB now equal to half X. And since angle ACB equal to 1 over 2X, we can substitute it here to angle ABC equal to 3 times 1 over 2X. 3 times 1 over 2X is 3 over 2X. So angle ABC equal to 3 over 2X. Now to find the exact value of X, since the sum of angles in a triangle is 180 degrees, we sum up the angles in the triangle. Now we have 3 over 2x plus 1 over 2x plus, and then equate them to 180. So here, 3 over 2x plus 1 over 2x, since the denominators are the same, we just add up the numerators. So we have 3 plus 1 over 2x plus x equal to 180 degrees. 3 plus 1 is 4. 4 over 2 is 2. So 2x plus x equal to 180 degrees. 2x plus x is 3x. So 3x equal to 180 degrees. Dividing both sides by 3. 3x over 3 equal to 180 degrees over 3. Here, 3 cancels 3. And here, 180 degrees over 3 is 60 degrees. So x equal to 60 degrees. Substituting x equal to 60 degrees here, 1 over 2x is 1 over 2 times 60 degrees, which is 30 degrees. Here, 3 over 2x is 3 over 2 times 60 degrees, which is 90 degrees. So now we have the angles of the triangle. And from this angle here, 90 degrees, it implies that the triangle is a right angle triangle. And when finding the total surface area of a right angle triangle, any of the two sides that are perpendicular to each other can be taken as the base or the height. So let's say this is the base and this is the height. Now from the SOHCAHTOA, this TOA means tan theta equal to opposite over adjacent. So let's take this angle here, 60 degrees. So theta equal to 60 degrees. Now from here, this is the opposite and this is the adjacent. Let adjacent equal to x, that is base equal to x. So now tan 60 degrees equal to opposite over x. Tan 60 degrees is the same as tan 60 degrees over 1. So tan 60 degrees over 1 equal to opposite over x. Cross multiplying, 1 times opposite equal to tan 60 degrees times x. 1 times opposite is opposite. Tan 60 degrees is 1.7321. So 1.7321 times x is 1.7321x. So opposite equal to 1.7321x. So that means if this is x, this must be equal to 1.7321x. Now height equal to 1.7321x. So substituting the values here, 1 over 2 times x times 1.73x equal to 3.46. 1 over 2.7321x is 1.7321x squared over 2. 1.7321 over 2 is 0.86605. So 0.86605x squared equal to 3.46. Dividing both sides by 0.86605, x squared equal to 3.46 over 0.86605. Finding the square root of both sides now, x equal to square root of 3.46 over 0.86605, which if you press your calculator equal to 1.9988. So x equal to 2 centimeters. Substituting here now, line AB equal to 2 centimeters. Here, 1.7321x is 1.7321 times 2 centimeters, which if you press your calculator equal to 3.4642. So now, also side BC equal to 3.4642 centimeters. Now what is the length of line AC? Still using the SOHCAHTOA tool, from this CH here, cos theta equal to adjacent over hypotenuse. Taking this angle here, once again, theta equal to 60 degrees. This here is the opposite, this the adjacent, and this the hypotenuse, because it's facing the right angle. So here, substitute 60 degree and adjacent equal to 2 centimeters. Cos 60 degree equal to 2 over hypotenuse. Cos 60 degree is 0.5. Making hypotenuse the subject, hypotenuse equal to 2 over 0.5, which if you press your calculator equal to 4. So hypotenuse equal to 4. And therefore, line AC equal to 4 centimeters. Now we have the length of the sides of the triangle to be 4 centimeters, 2 centimeters, and 3.464 centimeters. Thank you.